Hello, welcome folks to Tuesday night stream. We are going to talk about some more multicast stuff tonight. Making some progress on that today by various means. I've already launched the lab here. Hello, City CFC. Good to see you here in the chat. Hope you're having a good day. And Casadix is here. Faithful Casadix, good to see you, man. But yeah, we're gonna get this lab fired up here. Good to see folks again. Tuesday night. Hope everybody's having a good Tuesday night. I was tired, very tired tonight and last night, more than normal. Not sure why. Maybe it's a change in schedule, going to workouts early or something. But this stream is helping keep me, you know, on the clock, so to speak. So that's one benefit of the stream is sort of, when you have a regular time, you're scheduled to be there. Forces you to, get going. Newbie here. Hey, no problem. City CFC. Glad to have you with us. Yeah, so I've got a couple of just quick things before we do a lab. We're going to do lab on PIM, which is, of course, protocol independent multicast, designated routers, and forwarders, and what the difference is. That was something I ran into earlier today when I was studying, actually this morning. And I thought, let me hop on over to networklessons.com because I watched an INE video about it and I looked at the INE workbook, but I needed a little something more visual. So I went to networklessons.com and I was like, okay, good call, because I had some good info. I did lab on my home computer. And so what I need to do now is sync with the Git repo. I created a new lab topology on the home PC. Now I need to sync that up with the Azure copy. So the way to do that, it's not too hard. I know how these commands set up to do it. So I just need to SSH into it. And let's see, we wipe out. Let's see, we're going to take the Git repo and overwrite the evenG file. So all I have to do is go to the repo folder and do a git pull. It's a private repo, so that's why I have to enter password. And then we're going to wipe out what's in the labs folder currently. And at some point, oh, I didn't mean to do that. That's okay, though. Yeah, I just removed the labs folder. I needed that backslash here, but that's okay. We can fix that. And we're going to, we wiped the folder out, all right. I'll eventually get this into a bash script, but it's still kind of new, so. Then we update the permissions. And we should have now an updated labs folder. So what I should do here is I'm just going to log out, sign back in. And we might have to refresh here. Okay, it could be that I copied it already. Let me see. Oh, I typed, okay. Let's check our Git repo real quick. I spent a lot of time on Linux today, folks. I was working on some cloud stuff and okay, I thought there was, maybe I just copied it into here. What's the dates? Okay, 104. So we did, let me take a look at the lab. Nope, that is not it. So now I'm not sure. All right, let me go back to the local. Oh, by the way, we did have stickers to come in. So I ordered some Land Tamer stickers, and they're in. So if you ever win anything now on, sometimes I do giveaways, things like that, and I'll send you a sticker with those. Or if you see me at Cisco Live this year, I'll be giving out some stickers there. So some people like them. I myself, I'm not really a sticker person. Like, I don't. People give me stickers, and I appreciate them. I don't. The first thing I do though is not to put them like on the back of my laptop. I've never been that on my luggage. I don't know. I'm just not, I'm just not a sticker person, like that. But some people love them, man. They collect them, and so anyway. So what I've done here, folks, is I have launched the EvenG copy of the lab, and I built the lab earlier today on my local machine, and I thought that I copied it up to the repo. So that's what I wanted to work on in Azure, but I don't see it. So I'm going to boot up the local server and just check real quick. Yeah, I created an lessons here, and this is not the lab I created. So we're going to sync the repos again. I must not have synced them like I thought I did. This is running, of course, in VMware Fusion on a Mac. And this is actually the EvenG Pro edition on my local computer. That doesn't matter, though. They're compatible. The lab files are the same, the .unls. It'd probably take me just as much time to actually... Okay, here we go. Root. And I have a Git folder here. Okay, so here is a multicast pimassert.unl. That should have been copied up. Oh, you know what? I probably didn't add it. That's the problem. Okay. So we're going to do a git commit added pim assert lab git push. There we go. That's what I did wrong. All right. And we can shut them back down, come back here and say git pull. And now we have our lab file. To opt unit lab labs. There we go. Now I can just probably come back here, refresh, and there it is. So if you're going to have multiple lab instances, which I recommend anybody does, just because you never know when you're going to need a backup, and you just got to keep labbing. Plus, just for your own sanity, I find it helpful to be able to synchronize all the lab files between the locations. So someone today asked me, I released yesterday, the third video in the series of how to pass the CCIE written, and at the end of video 3, I had a panel that took you to the Azure, how to build a lab in Azure video. And someone asked today about being able to connect a virtual machine in Azure to other virtual machines in Azure or to the internet. And I have done that. It's not really that. It's basically the same as you would connect Eve to the internet. You know, like if you wanted to copy from a router, or you wanted to copy a file from the router to the internet, or whatever. You want to put a Linux VM in your lab and be able to install packages, right? To be able to do updates. The same way you would do that on like this computer at home. And in Azure is pretty much the same, with the exception that you need to use a NAT interface for sure. Like at home, I will use a bridged interface, and the Linux VM or anything behind that cloud will get its own IP address from DHCP. It doesn't quite work that way in Azure, so as long as you use a NAT address, which NATs to the IP of your virtual machine in Azure, then you're good. All right, so let's go ahead and console to all nodes, and this is what we're talking about. We've got this is a lesson on networklessons.com. Something that was confusing me. Again, multicast for the longest time has still been like this nebulous haze, and over time it's been clearing up slowly but surely. One thing I wanted to do tonight, folks, is look at sort of my schedule at my current pace. So let me pull up I want to make sure that I'm not going too slow in my pace. It's not like I'm going to set a schedule and then I have to finish all these lessons by that schedule. But at the same time, I don't want to go too slow. So what I've got left to do here, folks, is I'm at PIM Assert. So it's taken me a week, about 7 days to get to this. And I'm okay with that because multicast is just, it's a whole new beast for me. And things that I'm learning, not whole new. I mean, I passed, part of that is in the written exam. But in terms of, I've never really worked on it in production. And it's just a whole different concept. So the time I'm spending here, the extra time I've been spending here, I'm hoping will certainly pay off when I get to these other components. But I took the exam January 2nd, and it is almost, there's a week left in January. So I am going to need to pick up the pace here. IPv6 I look forward to. I don't see having a lot of difficulty with IPv6. QoS, however, even though this isn't that many labs, I expect to spend a lot of time here. So let's say we did these by months. If this was like mid-February, mid-March, end of April, then we have security and infrastructure, right? Oh, there's more. Okay, so let's just say January, February, March, April, May, June. Okay. That could get us then, if we did a month per section, give or take, this would get us through summer to here. And I'm okay with that. If I could get through all the major sections, then that would mean in summer I would start to hit these foundation advanced labs. And spend several months on these. So these are like, this is where you really hone your craft, getting fast, getting quick, and working on very large labs. Like some of these will take a whole day. There are 3 foundation labs, 3 troubleshooting labs, 3 full-scale labs, and 2 mock labs. This should be cool because this is like troubleshooting diagnostics configuration, troubleshooting diagnostics configuration. So there are 2 of these. This may not be enough. This is where I may decide that I need to get another workbook like Micronics or use the Cisco, formerly known as Cisco 360. So I just wanted to kind of peruse that again. Yeah, just more time. If I want to meet, my goal is by the end of the year to attempt the exam and get the CCIE. So, but I was getting stuck on the INE labs for this PIM Assert, so I thought, let me fire up a very simple lab here in Network Lessons. So the idea here is when you have a shared segment, right, there's different things that can happen. Obviously, when you have 3 routers sharing a segment, not everyone needs to forward the multicast stream. So that would be a waste. Let's say there's a receiver here and router 1 wants to send to router 4. There's no reason for him to send the stream, router 2 and router 3 to send it to router 4. And that makes sense. And I worked that out kind of during lunch today. I thought I said oh, it's blocked. I get a new IP every day, so I have to do that. I should script that. Oh, I did export. Now I want to console. Cool. Yeah, and the lab should already be built, unless the interfaces didn't come up. And they did. Awesome. So one thing I was trying to get clear in my head is the difference between a designated route, PIM designated router, and a PIM forwarder. And the designated router I know comes into play with dense mode. So let's see what we have running here. Show IP PIM neighbor. Sparse. So we have sparse mode, and the designated router and the forwarder is generally awarded, well, the designated router is awarded via highest IP. Whoever has the highest IP on the link, and in dense mode, that is who sends the prune. So for example, let's say we're running dense mode. And remember, dense mode, we send to everybody until they ask us to stop. So R1 will send to R2 and R3, and R3 will send to R4. And then, well, this is not a good, probably not a good topology to show that. But basically we have this segment here, and well, yeah, this works. So R4 may send a prune. He's going to say, hey, I don't need this traffic, right? And who will send it to, though, is whoever is elected the designated router on this segment. So instead of all 3, well, instead of both R2 and R3 sending it to R1, whoever is the designated router on this segment will get the prune and then forward it to R1 and say, look, R4 doesn't need it. I don't need it. So that is what the designated router does. However, the designated forwarder is different. And that is in sparse mode. And that is a lab we are doing right now. So the source in this traffic is going to be, or in this topology is going to be R1. And the receiver is going to be R4. So I'm going to take it, let me move this screen over a little bit. Yeah, we have 4 routers. When R1 starts sending multicast traffic, they'll both forward packets to R4 unless we have the elected PIM forwarder. So when R2 and R3 both forward packets to using these links, that would result, of course, in duplicate traffic. And the formula is different for who becomes the forwarder. In this case, it's who has the best, the lowest administrative distance to the source. So R1 actually show. Excuse me. I think we're going to send from the loopback. So if we look right here, show IP route 1.1.1.1. Excuse me, have OSPF running and the distance is 110. They should have the same. .110 metric of 2. Yeah, it goes by lowest administrative distance. If that is equal, it goes to unicast routing metric. In this case, that is equal. So then it goes to the highest IP, just like it would for a PIM designated router. And I'm afraid the part that was confusing to me, okay, this has a metric of 3, which makes sense because in this topology, 4 is going to be farther away than 3 and 2. So 3 should be the designated forwarder. Let's see if that is the case. Show IP PIM neighbor. Okay, I'm not sure how we determine the designated forwarder. Oh, well, this is done via dense mode as well. Okay. So there's a designated router and a designated forwarder concept in dense mode. What mode am I running here? DRS, I believe that's P, proxy cable, G, gen ID cable. It should show in the show IP PIM neighbor, DR priority, DRS, mode S. Interesting. I thought that command is what show IP. Dense. Okay, so we are running dense, I believe. Show IP PIM interface. That's where I see it. Yeah, dense. Okay, we're running dense here. So we're going to have a designated router and designated forwarders. And we have, in this case, I think we have an IGMP join here. Show IP IGMP groups. Yeah. Okay, 239.1.1.1. Excuse me, told you I was a little. Okay, yeah, we have IGMP in dense mode. Okay, so take it back. We are running dense mode here. So what should happen is if we send from R1 to R4, well, let's back up a little bit. So let's say we do a if we do an IP IGMP join, so we have a new receiver. Router 4 should send that as an IGMP join towards router 2 and 3, and then 3 should send it's the designated router on this segment. It should send the join to R1. I believe that's how that works. And then we get a star comma G, which we have. Null. And forward out GI01, yeah, to both. Okay. So let's do this. Let's add a new group, a new join. And let's look on, both GI00 and GI01 and see if we receive a join message. And if we do, with the designated router function, this should come from router 3, not from router 2, if I'm understanding this right. So I'm going to do a debug IP PIM. I think that's the best way to probably see it. And we're going to add a new join group. IP IGMP join group 239.333. So let's look over here at router 2, show IP mroute. Okay, so we have the star comma G. And we have it here as well. We should have received that's right. In dense mode, we're not going to forward it. Yeah, in dense mode, we don't send. So I thought we would send a PIM join. But we don't have any, yeah, we don't have, it's not necessary in dense mode. Now we will send a prune. Actually, let's do this. So let's ping 239.333, repeat 5. Okay, this is interesting. All right, so send V to assert. Show IPM route. Okay, so we router 2 told us to prune, so we do not. We're in the process of pruning from this interface, and the interface towards router 3 is in forward mode, but it is stopped. Okay, and then the star comma G, yeah. Okay, moving right along with the exercise. Let's do a show, I think we just did that, yeah, show IPM route 239.333. Okay, this is what was confusing to me earlier, so. Our outgoing list. Okay, these all say prune, yeah. And the forward 111. The forward is GI01. Oh, did I not do the correct interface? I did the wrong interface. All right. Let's ping 239.111 source. Okay, that's what I did incorrect. We were trying to calculate based on the loopback. So now, if we look here, show IP and route. Incoming interface is here, so traffic is incoming. The outgoing is GI01. It says prune dense. So what that means is, well, and if we look at router 3, should say forward dense. That's right. We're receiving on this interface. That's our IIL. Our oil is GI01. So he is the forwarder, not router 2. Router 2 is pruning. And then now, as it's saying here, if we want to influence this election of the forwarder, we can, if we're looking at the order, for example, administrative distance is the first thing used, right? So we can actually change how the selection works. The problem is we could change other things in the topology if we start messing with the administrative distance, right? So we're going to make this distance lower. And we're going to say access list 1 permit host. Okay, so what we're going to do here is we're going to say this route has a distance of 100 here. Show IP route. Show IP route 1.1.1.1. Distance is 100. Over here, it's still 110. All right, so let's see if that changed the election immediately. It looks like it did not. This is still prune. Wait a second. That should have changed. Show IP and route. Okay, now it's prune. I'll bet this is forward now. All right, it took it a second. We see this now transition to forward and this to prune. So let's take that back out. Router OSPF 1. Of course, there's different ways to modify the metric, right? It's mentioned here. We can change the cost of the interface. That would change the metric, etc. Okay, good. That's simple enough. I think I got it now. And now let's go back. Let me go backtrack a little bit to this DR again, because I thought that this topology would show us the designated router differences here. All right, that was a lesson before. And yeah, saying don't mix up the DR, PIM-DR and the DR forwarder elections. All right, this is a little bit different topology. So let me copy these configs in. And actually, I think I had a lab for that. let's just stop all nodes. We don't need to save anything here. And close the lab. And look at network lessons. Okay, so let's move this. And we're actually going to duplicate it or clone it and rename. This is going to be multicast PIM DR. Yeah, so let me just fire this one up. And can I mess with the startup configs here? Ooh, I can. Okay. So I'm just going to replace the configs. Will that work? I just like wiped out a whole bunch. Oh, let's do no shutdown. Let's try it. Well, what can we hurt? Okay, router 2. Yeah, we take that out. It'll add everything else in there. We're going to find out, aren't we? That's kind of cool, though. So in this topology, we're actually going to have rendezvous points. Okay, hey, let's see if this works. I'm already consoled. Let's see if it gripes about those scanty configs. Hey, it's a lab. We can break stuff, right? Do whatever we want. Okay, so in this case, we're going to have same scenario. We're going to have 1.1.1.1 as a loopback. And this is going to be the rendezvous point for the network. And R4 is only going to be a receiver. He's not going to be a host. A PIM router, I should say. He's going to be a host. Okay, yeah, I remember this now. Yeah, so the DR's job is to register with the rendezvous point. So what will happen is router 4, remember in sparse mode, someone who announces that they want to participate in a group, a multicast group, like a host, it's going to do an IPI-GMP join. It will send that join out onto the shared segment, which will be received by router 2 and router 3. Now, someone has to be responsible for letting the rendezvous point know that there's a receiver out here to form the star comma G tree, the rendezvous point tree or the shared tree. Just as an efficiency mechanism, there's no reason for both of these to send the PIM join message to R1. So that's what the designated router function is. It says, okay, whoever wins the election, that's the router that's responsible for forwarding the PIM join or generating the PIM join message. We will see in R2 that it has a star comma G entry, but it'll be null as an outgoing interface. R3 should win the election because the DR election process is very simple. It's either by priority, which you can configure by default as 1, or by the highest IP address. And in this case, if we're at the defaults, router 3 will have the higher IP address. But we're going to change it midstream. We're going to change router 2's priority. And that is... all right, let's see what these folks look like. Show IP PIM neighbor. None yet. Show IP interface brief. Okay, cool. It's a lot going on here. Oh, I didn't do no shut on these. That will remedy that. And we'll check out router 4. Okay, so now also in router 4, we have a join group 239.1.1.1. And okay, let's make sure we have our show IP PIM RP. IP PIM. What is the command? Show IP. RP mapping. Just gonna really think about that. Okay. So now the network should be a little more converged. Show IPM route. Okay, no one has that join yet. Is well, IP multicast routing is running. Oh, tunnel is down. All right, let's see why that is. Ping one. Aha, we don't have reachability. Interesting. Yeah, sometimes this happens with the lab. I think this happened to me yesterday. So we're going to enable OSPF so that everybody can learn about oops. Yep, he doesn't. That's why he doesn't have the tunnel. It's not up. Okay, so now we should, now our tunnel should come up. Huh, is the, this is up. Still not learning it. Oh, is the sender may not even be running. No, this is the auto RP. It should be here. Show IP OSPF neighbor. He cannot ping his neighbor. Are these interfaces different? Jazz 00, Jazz 00. Ah. Well, that's what we get for doing copy paste, right? Let's just reconnect the interfaces. Actually, I can do this. No, this is Community Edition. So let me shut these guys down. Oh, you know what we could do is just change them here. So this will be GI00, GI01, and this will be ooh, I like that. Now I found a use for that. GI00 and GI01. Also, let's do no shutdown. Oh, notice this priority is 100. So we have to take note of that. That is different than the default. GI00 and 01. Man, I like this feature. This is cool. I just sort of discovered this. Oh, I didn't save. Dagnabbit. Save. Save, and then 4 should be GI01. It's 00. Man, those are cool features. I like that. All right, so now let's restart everybody. I'm going to make a new flashcard about that, by the way. Let's do it. This will be a good question. Let's reconnect. Connect. I'm going over these every day. Lab exam practice, add a card. This is the primary responsibility of the PIM DR router. And it is to register the source that'll be a good review question. I love it too that Anki will sync. Like I just used it on another laptop earlier this evening while I was watching the news, and we're good to go. All right, so there should be some convergence here of the network. Show IP PIM neighbor. They still came down. That's all right. We have to go back and open all our interfaces. Okay. So did it not take the startup configs? I think that's what just happened. Yeah, it did not change those interfaces. I think there's a command to set all nodes. So I can set them to none. What exactly is happening here? I changed the startup configs. Do we have to close the lab? We shouldn't have to do that. If so, what's the sense in creating the startup configs? All right, see what happens. I think I've got it though. Like if I have to end up, because this doesn't have the right interfaces and we have to just trash the lab, then it's okay. I got my lesson. And if we look at all the network lessons has a lot on multicast, more than the INE workbook. Like it doesn't have pin prune override that I'm aware of. All right, let's see if it no, it's laughing at my face right now. So we'll just shut it down. It's getting close to wrap up time for me. We'll be back here tomorrow with some more multicast, I'm sure. And I think I'll have another YouTube video soon. The next one, let me see what it will be titled. I was trying to mention it on the video yesterday and I could not even remember. Yeah, here's the big agenda. So most of this is already written out, but evolving technologies. Yeah. That's what I'll be covering. And hopefully I'll be able to get that video knocked out tomorrow, but it takes a little bit out of me too, and time. The last video took me about, the recording was only 23 minutes or so, but about 3.5 hours of preparation aside from that. So anyway, that's going to wrap it up for tonight. Thanks so much, folks, for stopping in, sending you good bits across the universe. And hopefully things are going well for you and your studies. And we shall see you back here tomorrow, same time, here on the LAN Tamer stream. Have a good night.